Alright, evaluating logarithms. So what a logarithm function is it is in the inverse of an exponential. So for example, if we had y equals b to the x, to make this into a log equation, logarithms solve for the exponents. So first we're going to write the word log. The base of our exponent becomes the base of our log. So this will be log base b, so b is little. And then we switch the next two. So instead of it being b to the x, this will be log base b of y equals x. And it doesn't matter what those variables are. This is how we change them over. The big thing, the base of the exponent is the base of your log, and then you switch the next two. So for example, log base 2 of 8 equals 3. So 2 is the base of our log, so it is the base of our exponent. And then we switch the next two. So it becomes 2 to the third equals 8. Again, we're not solving for anything here, simplifying. We are just rewriting it in a different form. Alright, so the next one, the base of our log is the base of our exponent. So this is 4. And then we switch the next two. So it is 4 to the 0 power equals 1. 3, the base of our log is the base of our exponent. This becomes 12. And then we switch the next two. So I get 12 to the first equals 12. And then the last one, 1/4. It's the base of our log, so it is the base of our exponent. And then we switch the next two. So instead of it being 1/4 to the fourth, it's going to be 1/4 to the negative 1 equals 4. Alright, so now you guys try these on your own. Pause the video. Pause now. And then when you unpause, I'll have the answers up. So please pause now. 3, 2, 1. Alright, now check your answers on these. If there's any that you didn't get, please let me know. So write it down and then send me a message on Remind, and I'll be able to answer it for you. Alright, so evaluating a logarithm. There's lots of different ways that you can do this. What I've found easiest is to set this equal to x. And then from here, write this in exponential form. And it'll help you solve it. So 4 is the base of your exponent. It's the base of your log. So this becomes 4 to the x equals 64. Now the goal is to write 64 as 4 to some power, because it's this 4 here, so we want to write 64 as 4 to some power, so that these bases are the same. Well, 64 is 4 to the third power. And then what we do is we set the exponents equal to each other, because these base parts cancel out. So I'll just have x equals 3. So log base 4 of 64 equals 3. Alright, so 6, set it equal to x, and then you're going to write it in exponential form. So this is 5 to the x equals 1 over 25. Well, 25 is a fraction, and to get that 25 out of the denominator, that means it has to be a negative exponent. This is 25 to the negative 1. And then again, we need to make our denominators the same. So I can rewrite that 25 as 5 squared, and since it's already a negative 1 up there, it becomes 5 to the negative 2. And then your bases can cancel out since they're the same. And we get x equals negative 2. So log base 5 of 1 divided by 25 is negative 2. Alright, 7, set it equal to x, and then write it in exponential form. So I get 36 to the x equals 6. Now this one's a little bit different. I can't change the 6 on the other side. This 6 on this side just has an exponent of 1. But I can change that 36. I can break that down. 36 is 6 squared. We still have that x over there. And this equals 6 to the first. So now our 6's can cancel out. So I'll get 2x equals 1, which means that x equals 1/2. Log base 36 of 6 equals 1/2. And then 8. Do the same thing. I like to set it equal to x and then solve for x. So write this in exponential form. So this is 1/2 to the x power equals 8. Now in this one we can change both of them. The 1/2 side, I can rewrite this as 2 to the negative 1 because it's a fraction. Since the x is over here, it'll still be x. And I can write this 8 as 2 to the third. Cancel off your bases. So negative x equals 3, which means that x equals negative 3. So log base 1/2 of 8 is negative 3. Alright, now common log versus natural log. So common log here, if we have log base 10, this is the same thing as just writing the word log. So anytime you see just the word log written, we assume it's base 10. We also have something called the natural log. And what this is this is log base e. And e is a number like pi. It goes on forever and it repeats. It never repeats. And it actually occurs in natural log, which is why we call it the natural log. So instead of writing log base e every time, we write ln. And the thing, one thing to remember is that as we look at 9 and 10, logs and exponentials are inverses. They're opposites. So just like adding and subtracting cancel out, logs and exponents cancel out. So on 9, that log of 4 is really saying 10 log base 10 of 4. And if you have an exponent and log to that same base number, these cancel out. So my answer here is just 4. And on 10 it works the same way. We have log base 5 of 25 to the x. Well, instead of writing 25, we could write this as log base 5 of 5 squared, or 5 to the 2x, because the x is still there. And the log base 5, and 5 is the base of your exponent, cancel out, so this is just 2x. Now on 10, it kind of looks like the other ones, so we could have solved this the same way, but then we'd have two x's, and those x's don't represent the same things. So what I'd like you to do is try these problems, see if you can get them. A and B are like the first set of problems, and then C through E are like the ones that I just showed you. Alright, so pause now. In 3, 2, 1. Alright, so check your answers on these. And then if you have any questions, write them down and send me a message on Remind, and I can answer those for you. Okay, now we're going to be graphing these functions. And these are probably the most difficult functions that we're going to graph, not because that they're hard, but because we don't have necessarily a button in our calculator to do this. Your calculators do base 10, and so anything other than base 10 or base E, your calculator's not going to be able to do. So, when we're looking at y equals log base 3 of x, to graph this, I'm going to write this in exponential form. So 3 is the base of my log, and then I switch the next two, so it's 3 to the y equals x. Now, when I make these points, this is kind of just like how we did Monday's notes, but because y is the exponent, we're going to pick y values. Remember, we always pick these -2, -1, 0, 1, and 2. Now, I'll tell you that most of the time, this is going to be too small to graph, and sometimes even the next one. But if you can graph it, go for it. So, when I plug in these y values, the x value, this becomes 3 to the -2, which is 1/9. 3 to the -1, which is 1/3. 3 to the 0, which is 1. 3 to the first is 3. And 3 squared is 9. So I'm going to plot these points. Again, this one is too small for me to graph. I could make a point over there, but if you don't, that's not a big deal. Alright, then I've got 1/3, -1, and then 0, 1. Right. And then 3, 1, and then 9, 2. Now, just like exponentials, they had a horizontal asymptote. This one's going to have a vertical asymptote. So I'm going to have a vertical asymptote here at x equals 0. So at this line. And then I connect these points. Follow like a asymptote. And that's your graph. Your domain for this function is left to right, so my furthest left is 0, where my vertical asymptote is, to the right, which is infinity. And your range for these logs is low to high, and all of them will be -infinity to +infinity. So even the domain and range parts flip as well. Alright, so now 12 log base 2 of x plus 3 plus 1. So first, this x plus 3, you have to use your transformation ideas. So inside moves your graph left and right, and it's opposite of what you think. So this is going to move our graph left 3. This plus 1 on the outside is going to move it up 1. So what we're going to do is we're going to find the graph of y equals just a normal log base 2 of x. And then we're going to transform those points based on my left 3 and up 1. So remember, with logs, I don't have a log base 2 button in my calculator, so I'm going to put this in exponential form. So this becomes 2 to the y equals x. So we pick our y values. So when I pick my y values, we pick -2, -1, 0, 1, and 2. And I plug them in for y to get my x's. I plug in -2. This is 2 to the -2, which is 1/4. I don't know if you guys can see this color very well. Then we'll have 2 to the -1, which is 1/2. 2 to the 0, which is 1. 2 to the first is 2. 2 squared is 4. I could even do another point if I wanted. 2 cubed is 8. So these are the points for this function. But now, so we need to graph these transformations. So my x values, I'm going left 3. So to go left 3, that means I subtract 3 from all of these x values here. So 1/4 minus 3 is -2.75. 0.5 minus 3 is -2.5. 1 minus 3 is -2. 2 minus 3 is -1. 4 minus 3 is 1. And 8 minus 3 is 5. Now for the y's, this is your +1. You're moving up 1. So what we do is we take all of these y values and add 1. So I'm going to add 1 to all of these y values, which gives me -1, 0, 1, 2, 3, 4. And then what I'm going to do is plot these points. So we're done with this table. These points are the ones that we're plotting, because remember, this is the graph that we're plotting here. So I plot these points: -2.75, -1, -2.50, -2, 1, -1, 2, 1, 3, and 5, 4. Alright. I also need to get my vertical asymptote. Remember, your normal vertical asymptote is at x equals 0, but this has gone left 3. So now my vertical asymptote is at x equals -3. Connect your points. Your domain is how far left and right, so the furthest left it goes approaches our vertical asymptote of -3. Then it goes to the right where there's an arrow to infinity. Your range is your low to your high, and it's always going to be -infinity to +infinity for logarithm equations. Alright, then the last one for the notes is the you try. So you go ahead and try this and see what we get. So that means you need to pause the video now. So pause it in 3, 2, 1. Alright, so here's the answers to the you try problem. So go ahead, look it over, make sure your graph is somewhat close to this. The big thing you could look at is if your points are the same, so if your x and your y columns are the same. If not, take a picture of what you did and send it to me, and I'll try and correct it pretty quickly. Alright, and I will see you tomorrow.